Did Nvidia just give robots common sense? I mean, seriously, have you been wondering if that massive gap between advanced AI and actual physical robotics is ever going to close? Well, today in this explainer, we're diving into how Nvidia, Unitree, and Sharpa are teaming up to create a brand new open reference blueprint, one that might finally unify state-of-the-art AI with physical hardware. We are officially moving beyond theoretical models and looking right at how real intelligence is being deployed into the physical world.
To wrap our heads around this monumental shift, we're going to break down three massive upgrades. We're talking about the body, the brain, and the desktop. And what's really fascinating here is that this is a totally concerted effort to rip AI processing out of those distant cloud servers and drop it directly into local, physical environments.
Here's our roadmap. We'll be exploring the Open Robotics Blueprint, building the physical body, the Cosmos 3 robot brain, and finally, what local AI for everyone actually looks like.
Let's start right off with the Open Robotics Blueprint and how we are moving beyond the black box. Historically, working with advanced robotics meant you were locked into proprietary systems. You were stuck with these black boxes that you just couldn't fully access or modify. Nvidia is trying to completely shatter those limitations with the Isaac Groot reference humanoid platform. It's an entirely open foundation blueprint built for academic research, and it's powered by the onboard Nvidia Jetson AGX Thor T5000. It is genuinely wild to think about a Blackwell architecture GPU running right on this system, processing real-time inputs from a complex multi-view sensing suite. It's handling a head-mounted binocular camera with a super wide field of view, plus optional ultra-wide-angle wrist cameras for close-range tracking, all instantly.
And all that hardware feeds seamlessly into a complete end-to-end software loop. First, you have Isaac Teleop capturing raw human demonstration data. Then, that data feeds directly into the Isaac Groot foundation models to train complex, multitask behaviors. Step 3 is the rigorous testing phase. Training and evaluation happen entirely within the Isaac Sim and Isaac Lab simulation environments. And finally, the Isaac ROS middleware lets you deploy those newly learned policies straight onto the physical hardware.
Next up, let's talk about building the physical body, specifically utilizing the Unitree H2 Plus and Sharpa hands.
So for this open architecture, Nvidia is leaning on the Unitree H2 Plus chassis, and it's a genuinely formidable machine. It stands 6 feet tall, weighs 150 pounds, and runs on a 1 kilowatt-hour smart battery that gives it up to 3 hours of operation. Base hardware tasks are processed on dual onboard Intel Core i5 and i7 processors. But honestly, the raw physical power is what's most striking here. This thing produces a maximum leg joint peak torque of 360 Newton meters. Unitree is actually aiming to start manufacturing and selling the H2 Plus by late 2026.
75. That is the total degrees of freedom across the entire chassis and limbs of this robot. The H2 Plus body alone handles 31 degrees of freedom. That's 6 per leg, 7 per arm, 3 in the waist, and 2 in the head. But the real magic happens when you add the lightweight Sharpa hands. They weigh just 2.8 pounds each, but they dedicate 22 active degrees of freedom per hand, bringing the total system to a massively flexible 75 degrees of freedom.
And speaking of those Sharpa hands, 1,000. Astonishingly, there are over 1,000 embedded tactile sensors packed into just a single Sharpa fingertip. All of this localized, dynamic tactile data is constantly being managed by a dedicated neural network-based sensing algorithm.
These hands can handle a structural payload of 30 kilograms, or about 66 pounds. They maintain a grip force of 150 newtons. But get this, here is the most staggering part. They have a sensitivity threshold of just 0.005 newtons. These aren't just dry specs. They translate directly into incredibly fluid, highly sensitive manipulation capabilities for a physical robotic body.
But look, hardware is only half the equation, right? Let's dive into Cosmos 3, the omnimodal robot brain. The old approach to robotic AI was, frankly, incredibly clunky. Robots had to rely on completely separate, fragmented models to listen, read instructions, process vision, and then finally calculate motor outputs. Cosmos 3 totally obliterates that fragmentation. It unifies all those modalities into a single, massive mixture of transformers architecture. So it isn't just a basic video generator, it's practically a full-scale world simulator that links perception directly to physical execution. Cosmos 3 can fluidly switch between vision-language reasoning and robot policy execution because it handles text, images, video, audio, and physical action sequences simultaneously. Because it's processing all these inputs at exactly the same time, you can just feed the model a single string of text or a quick video, and it accurately predicts the physical trajectory needed for a task, no pre-programmed coordinates required.
And the results of this unified architecture speak for themselves. Third-party benchmarkers like Artificial Analysis have ranked Cosmos 3 as the absolute #1 open-source text-to-image and image-to-video model out there. RoboArena also ranks it as the best active policy model for robotics. And the best part of all this? Nvidia entirely democratized this state-of-the-art intelligence. They just released the code, the model weights for their super and nano models, and their synthetic datasets to everyone.
So the robots are getting dramatically smarter. But this push to make AI accessible is also coming right to your desk with local AI for everyone, driven by the RTX Spark.
Announced at Computex by Nvidia and Microsoft, the RTX Spark is a brand new consumer system on a chip, co-designed with MediaTek. This hardware is built from the ground up specifically to run local AI agents. It integrates a 20-core ARM CPU, a Blackwell architecture GPU, and up to 128 gigabytes of unified memory directly into a whole new generation of laptops and desktops.
RTX Spark delivers 1 petaflop of local AI compute. That is an insane amount of power. It allows you to run massive 120 billion parameter language models completely offline, equipped with up to 1 million token context window. Just imagine the speed of running massive AI workflows, like localized agents managing your files or rendering high-res video pipelines, all done instantly on your machine without sending a single byte of your data to a cloud server.
Now, obviously, running powerful autonomous agents locally requires some serious security. To handle that, Microsoft and Nvidia built native Windows security primitives right alongside a new framework called the Nvidia OpenShell Runtime. This robust security framework safely sandboxes open-source agents like OpenClaw and Hermes. It basically ensures that your localized AI agents can execute really complex cross-application workflows safely, keeping everything tightly controlled on your personal device.
All of this points to one massive shift: the next computing era.
Nvidia's Jensen Huang summarized this momentum perfectly at Computex. He said, computing is shifting away from traditional application clicking toward localized AI agents that execute tasks via natural language. Empowering our physical hardware and consumer desktops with this kind of localized, highly sensitive, open-source intelligence is undeniably where we are headed.
So as we wrap up this explainer, I want you to consider this. We've seen how NVIDIA's tearing down the black boxes of robotics and bringing petaflops of compute right to your desktop. How will this massive shift away from the cloud toward localized open-source AI completely reshape the way you interact with your own devices? Ponder that for a bit. And hey, don't forget to like, subscribe, and keep exploring the future with us. Catch you next time.